Alright, welcome back to another video where we go through some past paper questions. So today we're going through the 2020 independent paper for physics. So this question is to do with Module 7, Inquiry Question 3, and we're looking at When's Law. Okay, so let's have a look at what the question's saying. It says the graph below shows the wavelength of the peak intensity radiation emitted by a standard black body at different surface temperatures. So this is a diagram that we have in front of us. And it kind of says temperature dependence of wavelength maximum radiation intensity. So for those of you who need a refresher or might have forgotten, When's law states this equation here. So lambda B over T. And if we actually have a look at what the formula is trying to show us, it's trying to say that lambda max, the wavelength with the maximum, so wavelength with maximum intensity, will be told to us by the constant lowercase b, which we call When's displacement constant. And that value is known to us as 2.898 10 to the power minus 3, and also temperature. Now, temperature is measured in Kelvin. That's the standard units. That's why we have this unit here. Okay. Assuming that B is a constant, okay, so value doesn't change, what we can see is the maximum intensity wavelength we see will be inversely proportional to the wavelength. So not wavelength, sorry, temperature. So as temperature increases, the maximum intensity particular wave, okay, will be smaller. Okay, so that's what we're assuming here. If temperature was to go down, so the body was to go down, then the maximum intensity wave that we see on a black body will be higher. So let me just draw two graphs to just kind of show for it. So assuming that we have an object that's at maybe 3000 Kelvin, we'll see, and this is the wavelength, we'll see the chart look a bit more like this. Oh, sorry, wavelength over here. And this is the large side. So we'll see that the wavelength is closer towards the higher values, which means we're looking at maybe, red light, infrared, something like that. If we have a really high temperature though, they'll shift our curve more to this side here. As you can see, the two differences in the shape. This one will potentially be more UV light, blue light kind of thing there. As you can see, it's a lower number in terms of wavelength, but the maximum intensity is for the lower number. Okay, so that's kind of what we're seeing here. Okay, so the question says, show that this graph is consistent with When's law. Well, you can see here from the diagram, it is going down. So it is sort of exponentially decaying like so. So that is showing that inverse proportionality that we're seeing here. But obviously it is 4 marks, so it's not good enough to just say it's showing the inverse proportionality formula. We need some actual mathematics to prove it. So what we're going to do is going to interpolate. So interpolate means we're going to use particular points on this graph, say this point here. We use particular points on the graph and we're going to try and calculate for the constant b. That's the easiest way of going about it. Some of you might want to find using the value of lambda max and the constant b to find t. That's okay too. But we do know that b, the actual number it is, so we'll go with that. So we'll go with that point there. We will go with this point here. we will use this point here, and we will use this point here. The reason why I'm using 4 points is because the question's worth 4 marks. Okay? When you're doing questions like these where you're trying to prove a law and it's some calculation, try and match the number of marks in terms of the number of points you might want to use. So obviously this might come down to your ability to interpret the actual lining of the graph. So there might be some error in or some uncertainty in the numbers, but it should be pretty close so long as you make sure you have a ruler to help you do the lining here. Okay, so from what I have here, where we have the coordinates of lambda max is equal to 6 micrometers, and then temperature is about 100, or not 100, 500 Kelvin. Let's do the calculations for that. Well, actually, I'll make my layout for all of them first. So we have that. We have lambda max at 5 micrometers to about 600 Kelvin. Lambda max. That one looks about 750. Just make a rough estimate. Then lambda max. Okay, cool. So let's do some calculating here. So the formula we have is lambda max over b over t. So in order to find the value for b, it'd be lambda max times or multiplied by t. Okay, so grab your calculators out, do those calculations there. And we are dealing with micrometers, so if we want to convert that into meters, it's 10 to the power minus 6. Do make sure you are comfortable with each conversion, or at the very least, remember how to do the different conversions of units. Okay, let's do the calculations quickly. Okay, so the first one we have is approximately 3 times 10 to the power minus 3. Let's do the next one. This one is also about 10 to the minus 3. Ten to the power minus 3. And also 10 to the power minus 3. So we can see that we're getting constant value for b, which is good, okay? Because we're saying that in Wend's law, b is a constant. So the fact that we're getting that is a very good sign that we're following that law. Now let's just look at the actual number. So the actual number is 2.898 10 to the minus 3. So we're within this very similar values here. Okay. So what we've actually done, we've actually shown that we are being consistent with Wend's law. We have shown that b is a constant here. So now that we have shown the evidence, we need to make a conclusion to this question. So therefore, the value of b in this graph is constant for the points used. The value calculated is similar to the theoretical value of B. So this is just sort of concluding what we're saying. Okay, so therefore, so the theoretical value of B, so this graph is being consistent with When's law. Okay, so we've looked at the evidence, calculated the evidence. So our evidence, if we try and break it down, this is our evidence here. And this blob here, that's our judgment, that's our conclusion. Okay? So that's how you do that question there. That's worth 4 marks. This is the type of things that you'll need to include if you want 4 marks. So that's quite different from the types that we have done so far on this channel and that we have recorded. So hopefully that gives you a bit of context of how to tackle these kind of questions in the future. Now, have a good day. If you want to check more about this particular inquiry question, the quantum theory of light, there will be a playlist for inquiry 3 in one of the screens here. So please make sure you check that out for further reference.